A company sells insurance policies for which benefit payments made to each policyholder are independent and identically normally distributed with mean 2475, standard deviation 250. Calculate minimum number of policies that must be sold for there to be at least a 99% probability that the average benefit paid per policy will be no greater than 2500. So since we are talking about an average, so this calls for central limit theorem, which does apply in this case. And so by central limit theorem, we know that the mean of the average is just the mean of each variable, and the standard deviation of the average is the standard deviation of each variable divided by square root of n, where n is the number of variables. So and if n policies are sold and S is the average benefit per policy, so then in this case, we instead of X bar, we're just calling it as S. So mean of S would be 2475 because the 2475 was the mean for each policy, and the standard deviation would be 250 divided by square root of n, where 250 was the standard deviation of each of the variables. And now we are looking for probability that the average is less than 2500. And also, we are interested in the probability being at least 99% that this average is less than or equal to 2500, which is another way of saying no greater than 2500. And now the next step will be to find the z-score corresponding to a cumulative probability of 99%, which from the tables here we can use this bottom row, which conveniently describes some of the commonly used values. So for 99%, which is a cumulative probability of 0.99, we have z is 2.326. And so 2.326 is, so we are looking, remember, we're looking for probability as less than equal to 2500 to be at least 0.99, to be at least 0.99. So the z-score equation would be z is 2.326, as we just saw, equals x, the value of interest is 2500 minus the mean, which is 2475, divided by the standard deviation, which is 250 divided by square root of n. So you bring the 250 over square root of n on the left side and you divide by the 2.326, and then we take the square root of n on the right side, and that ends up being 23.26, and therefore when you square both sides, n is 541.03. So this corresponds to 99% probability of average benefit being in the desired range, average benefit being less than 2500. So we need this probability to be at least 99%. So the calculations are showing that a sample size of 541.03 will give us 99% probability. So a greater sample size which will actually give us even more probability of having what we want. Therefore, and since the sample size has to be an integer, so our sample size has to be greater than 541.03, greater than or equal to 541.03 to have the probability at least 99%. And the next integer after 541.03 is 542. So therefore, we need a sample size of at least 542 to meet the required conditions, and that is choice B.